Hi everyone, welcome back. So in this video, we will be building a simple RTSP video streaming server using GStreamer in C. Basically, uh, what RTSP is, we will be explaining that, and then try to build the application in using GStreamer using the GStreamer APIs. Also, by the end, you will be able to stream a video from your machine and play it on VLC or any FF Play client over the network. So to start with, let's have a look what RTSP video stream pipeline looks like. So if you look here, there is a pipeline given which is having the RTSP source element, basically pointing to the location where um, the video will be streaming from there, and then getting the packets, uh, getting the packets into H.264 format, and then parsing it basically, and then converting and finally giving into the video sync where you want to play it. So this is a basic RTSP pipeline that we will be trying to build in GStreamer. Yeah, so first let's try to install the dependencies, right? So we'll open the terminal here and we'll do some dependencies installation. That is the GStreamer plugins and the GStreamer development plugins and the RTSP server plugins and the build essentials packages. So I have already given this, a command that we can run. So if I run it, so few packages are already installed on my system. As you can see, um, this RTSP servers and all packages will be installed. And just let's proceed further. Right. So once the packages are installed, so since I am on Linux system, right? So we have to use the Linux dependencies and all. So once it is done, we can similarly can be modified with the any other platforms for GStreamer. So right now it is kind of a WSL environment what I am running on, not completely on Ubuntu, but it is a WSL environment. So start with we'll um, proceed with the folder structure. What we'll have is basically source, or you can just name the project folder as RTSP streaming, right? Then we'll make a folder as source, right? And then yeah, so we'll be making a main.c file and make file for building the and making the project, right? Sorry, these two will be sitting outside the source file. Correct. And we can add a readme file as well, e.md, which will explain the dependencies and what is exactly what we're doing here, right? That we will be adding it. Also, to continue, we will be having a RTSP source file. Basically, that is a C file that all the projects will be there. So inside the source file, we will be having this RTSP server.c. So it will be inside the source file. Okay. So we have this and then main.c and then make file in the readme.md file. Yeah. So let's start with the coding part directly. We'll jump into the server, making the server creation, and we'll see how we can do the makefile and the readme file later. So we will be including all the GStreamer and RTSP server headers here. So if I go with the server code, let's start with adding the header files. And then the Copilot is automatically suggesting me to, continue with the header file as well. Just I'll do tab and then it will select it. So next is including the studio, not studio, sorry. This is the local user-defined header file that will be um, RTSP, RT, right? So these are the includes. So we have to maintain an header file as well here. So we'll go to source, we'll create with the same name, RTSP, correct? Right. So this is done. Yeah. So let's jump into the code part. We'll just define a function that is don't go by the Copilot thing. Actually, it is taking it as a, you know, just defining it yourself. So RTSP, RTSP, GST, server run factory part. After that, we need a gchar star pipeline, pipeline descriptor, right? That will take the pipeline description, basically what pipeline we need to run. Okay, so yeah, right. So okay, so next is just calling the GST init function. Copilot takes it correctly. I'll just do tab. It has, you know, thought of this basically APIs and also that inside it is thinking the right way. So let's define the server. Server equals to GST RTSP server new, right? And then we'll set the object to the server service with standard printf port, right? This is correct. And then mounts. Okay. Now let's define a pipeline. So pipeline example pipeline. So right. So example pipeline. I could take as there will be a camera source, then it will be H.264 encoded, correct? 264 encoded, and then it will go to the RTP payload, right? So let's start with the pipeline. Actually, the Copilot is suggesting me the right pipeline that is correct only. Okay, just I'll do tab. So once this is the pipeline that we will be trying to build, and RTSP server will be trying to run on the server side. So you can see there is a video before to source that will be taking the camera input, or we can just use any file source as well. We'll try with the v4l2 source and check how it works. Then video convert for converting the proper color format. Then encoding with a X264 ENC, that encodes into H.264 codecs. Basically, these are the properties set for that: zero latency, and the bit rate we have set as 500. Speed preters are super fast, taking the proper usage of the CPU resources, and then packaging through the RTPH H.264 pay. That these are the properties set that, right? Okay, so once this pipeline is built, let's pass other parameters. So basically, we need a GST RTSP media factory set launch that will take the pipeline and getting the factory as a parameter and taking the pipeline as a parameter. Then we'll go to the GST RTSP media factory set shared. That will be set to true, and then GST RTSP mount point set, that will be kind of getting the mount, basically mounting the server onto the port where um, the video will be playing, and then unreferencing the mounts once everything is done. Also, we'll add this GST server attach that will be set to null, right? And then printing the status of that RTSP server, where what is the status and where it is running, right? So we'll be printing this at this local host itself with the port number and the mount point, right? And then basically running the loop, which will uh, you know initiate the pipeline to run. Okay, so this is all the source code what we need to include. Let's jump into the main file to write it, right? Yeah, so in the main file, we need to write the main function. Before going to the main file, let's go to the header file and define the definitions and the function definition, function declaration here so that it links properly. Writing the header guards, right? Correct. And then defining the function that is already taken care by the Copilot, right? And then okay. So this is the header file. We'll go back to the main function where we can start the main loop. So we'll include the and then start writing the main function, which takes the int argc. So we'll take the port as 8554. That is the default RTSP port, and then we'll go to constant char. That is a string defined as a test, kind of a mount where we will be using our application to mount itself in the server and try to run it. Okay. Then we'll check if the argument is greater than 1, then basically going to the converting the argument type into the integer and then using it. And we can check for other um, if it is greater than 2, then use the mount point as a second parameter as an argument. Okay, so let's close this if condition. Now we'll call the function that is our TSP server run with the port and the mount point, and then finally return 0 if everything gets successfully executed, right? Yeah, so this is all what we need for the coding side for the RTSP server and the header file and the main file. So we need to run the source codes, right? So we need to make a makefile as well. So makefile, how should we start? So basically, makefile is just for building the project and defining all the source code, what we need, and defining all the libraries we need and linking them. And then we need to run the make command so that everything gets linked and all the source files are getting linked, and then we generate a target, which we call as a binary target, right? So we'll start by putting the compiler as GCC, right? And then we'll put as C flags. So automatically the copilot is taking that. So I'll just review it to a tab. Next, it's asking for the libs libraries, what we need. Okay, next we'll add the sources, right? So source will be having the source RTSP server and basically the source and the main file as well. So let me check. It should show the main file. Okay, it's not showing, so we'll just write main.c here. It's not into the src folder, right? So main.c, correct? What is the object what we need to do? So object is getting as getting the high dot o file, and then target would be our RTSP server, or you can just name it as GST RTSP server. Okay, right, right. So this is all what we have to put as dependencies. So we'll define all the targets what we have. So we have all, which will take the target as an input, and basically we'll have the target, the object file, and basically the copilot is helping me a lot. CC with the flags, actually we need to add the C flags here. So if it is called as clean, then we'll have to remove the object and the target file, correct? So I believe this is the make file what we need. So I think we are ready with a kind of a short demo where we can test this code. So before moving further for testing and running the source code, right? So we'll go to the server file and we'll change the pipeline as because there is an issue with my web camera. So we will be, just running a test pipeline, test video test source as a pipeline. So we'll remove these things and just use a simple pipeline, which will be having a video test source, encoding it, and then sending it to the RTPH packet, right? So let's try to run this pipeline and test whether it's working or not. Okay, so we'll start by running the makefile. We'll open a terminal, right? We'll do a ls. Let's check the folder. We'll go inside the folder. So there is a makefile, main file, and a source folder, right? So we'll do make here. Oh, there's an error. Okay, so it is saying me to use gprint. Okay, let's go to the line. Oops, gprint. This is a typo, I think. Use gprint here, right? And then there is no such file directory. Oh, I think since main is outside, right? So it won't take it. So we need to go to the src folder and then use it. So that is a change. Let's clear this terminal. Let's try to make first. Yep, I think there is a small warning also. There's implicit declaration of the function a to I. I believe I have not used the any header file for it. Anyways, we have got this object right here, basically having the uh, you know the application what we need to run. So we'll start running the application. Let's see. Yeah, so this is the object file what we need to run, right? So for running it, we need to, in the main function, as you see, we have a port and there is a mount point. So mount point basically is the test path what we need to, give it as a second parameter. So we'll for running it, we'll just start by dot slash GStRTSP server. We'll give the port number as 8554, which is the default port number for RTSP server, where RTSP server runs. By default, it is the same. And then we'll give the second parameter as a mount point, which is the test thing, right? Then we'll just click enter. Yeah, so you can see this is running, it says RTSP server is running at the, this address RTSP. It says the uh, localhost IP and then the port number is 8554 to dot list. Yeah, so I think there is an issue while I run the uh, video via a browser. I think there is a timed out happening. So what I'll do is we'll go to the mm, server side. So server side, as you can see, it is running, basically listening to the clients, whatever clients will be connected to the server. So what we have is tool called there is a tool called ffplay, right? ffplay is a client that is taken from the ffmpeg utility. So basically, it is a client that will have the uh, command like this RTSP, uh, basically typing the whole URL where the server is listening. So we have this as set it correct and set the port as 8554 and the mount point as test. So if we run this command, it will play a video that will be, used to display whatever the server is running. So before that, you need to install the basic ffmpeg tool that we can do using this command sudo apt install ffmpeg. Correct? I just installed recently so it will not ask for me again. So if I run this command, what it will do is it will display all the video formats, whatever configuration is there, right, for that particular video. Basically, what all libraries we are it is using, what all the scale is, basically the metadata, RTSP server, duration, stream, the H.264 formats, and these are the parameters and format specific to the video things. So you can see there is a around 30 FPS we are getting, and these are the parameters what it is showing for the video. So there is a window appear, so I'll just pull in into my display here. So as you can see, this is a window basically playing a video test source file on the screen. So the pipeline what we have defined, right? So if you can see in the uh, test pipeline, that is the video test source getting encoded into X264 ENC and then packetizing into the RTSP, you know, server. So yeah, that's it. And this is how the you can say video streaming protocol works. That is the RTSP. Yeah, so that's all. Close this, and I believe there is a README file left. What it will be describing the project structure and the dependencies what we had installed. So I will be posting my GitHub link, and the repo will be pushed into the my GitHub link, and you guys can have a look at the code as well and suggest me any improvements or any better way of designing this thing, right? Yeah, so if I talk about the specific applications of this thing is kind of we can use this RTSP protocol in video surveillance systems. Uh, like suppose the CCTV camera systems, what we have for traffic analyzing and anywhere, any security cameras, IoT camera streaming also, and the cloud multimedia servers where cloud in the all the cameras are connected to the cloud, and you have to monitor the live streaming procedure there. Yeah, that's all, folks. That is how RTSP server protocol is, video streaming protocol is made, and uh, that is what it is. Thanks for your time. I'll catch you in the next one. Thank you.